Welcome to the deep dive. Today we're getting into something that trips a lot of people up, those word problems in math class. We're talking about translating them into simple equations you can actually solve.
Yeah, and you sent over a great chapter that really breaks this down.
Exactly. So our mission here is to pull out the core method, the key takeaways from that material. We want to give you a shortcut to understanding how to tackle these things head on.
It's a really good source for this because it turns what feels like, I don't know, a confusing puzzle into a clear process, something repeatable. And the real insight isn't just getting the answer, it's the method. That's the key.
Okay, let's unpack that then. The source gives us a four-step guide?
That's right, 4 steps. Think of it like building a little bridge from the words to the numbers.
All right, step one.
Step 1 sounds basic, but it's so important. Read carefully. You got to figure out exactly what info you're given, and maybe even more critical, what are they asking you to find?
Right. If you don't know the destination, the map's useless.
Exactly. If you miss what you're looking for, well, the rest just falls apart.
Okay, so identify the goal. What's step two?
Step 2 is where you represent that unknown thing, the thing you're trying to find, with a letter. Usually X, right? But it could be Y or N, whatever. It doesn't really matter. But you need to give that unknown number a name, a symbol.
A placeholder.
Yeah, exactly. A placeholder you can work with. Because you need that for the next bit.
Which is step three, the translation part, where the magic happens.
That's it. Step 3, writing the equation. You look at how the problem describes things relating to each other. Phrases like is added to, is 3 times, the total is, You turn those phrases, those conditions, into math symbols. Plus, minus, equals. And you build an equation showing how the numbers you know connect to that X you defined.
Okay, this sounds like the part where people might get stuck.
It often is. But if you did steps 1 and 2 right, the careful reading, defining the unknown, makes this step much, much more manageable.
Gotcha. And after all that setup, step 4 is the solution.
Step 4 is the payoff. Solve the equation you just built. Use your standard algebra toolkit, move things around, isolate that X, and find its value.
Okay, let's make this real. The source has examples. How about this one? If 8 is added to twice a certain number, the sum is 36. Walk us through the steps.
All right. Step 1, read carefully. We need a certain number. That's our unknown. Step 2, let's call it X.
Okay.
Step 3, translate. Twice a certain number. That's 2X.
Right.
8 is added to that. So 2X plus 8, the sum is 36. That means it equals 36. So our equation, 2X plus 8 equals 36.
Nice. And step 4, solve it. Subtract 8 from both sides. 2x equals 28. Divide by 2, point x equals 14. The number's 14. Wow, okay. It really does seem straightforward when you follow the steps like that. That sentence sounded like a riddle before.
It's that systematic translation. That's the power. Let's try a slightly trickier one from the source. An age problem. These always sound complicated.
Oh, yeah, the age ones. Okay, what is it?
A man is 26 years older than his son.
Yeah.
After 10 years, he will be 3 times as old as his son.
Okay, definitely sounds more involved. Where do we even start?
Step 1, read. We need their current ages, plural. Step 2, define the unknown. Let's make the son's current age X. It's usually easier to pick the simpler quantity.
Why the son?
Because the father's age is given relative to the son's. So son's current age is X. That means the father's current age is X plus 26.
Okay, makes sense. But the condition, the 3 times as old part, that happens later.
Exactly, after 10 years. So we need their ages then. In 10 years, the son will be X plus 10 years old.
Right.
And the father, he'll be his current age, X plus 26 plus another 10 years. So X plus 26 plus 10.
Which simplifies to X plus 36.
Perfect. Now step 3, the equation. Use the condition after 10 years. Father's age will be 3 times son's age. So X plus 36 plus 3X plus 10. See, the structure holds.
Okay, now we solve that. Let's see, X plus 36 plus 30. Move the X's to one side, numbers to the other. 36 minus 30 is 6, and 3X minus X is 2X, so 6 is 2X.
Yep.
Divide by 2, X equals 3.
So X, the son's current age, is 3.
Which means the father's current age is 3 plus 26, 29.
There you go. And what's really neat there is how we handle time. We defined ages now, calculated ages later, and use the variable consistently to link it all in one equation.
That's the key, isn't it? Keeping track of what X means and when.
Absolutely.
And the source mentions this same four-step method works for other types too, like consecutive numbers or shapes or money problems.
Yeah, things like consecutive numbers differing by 1 or odd EV numbers differing by 2 or finding the length and width of a rectangle or dealing with coins. It's all the same fundamental approach. Understand what's asked, define your unknown, translate the relationships into an equation, and then just solve the math.
So what's the big takeaway for you listening?
I think it's that these word problems, which can seem really daunting, aren't usually hard because the math is hard. It's the translation. It's turning the language, the description, into that mathematical structure. And this source provides a clear, systematic way to do that translation.
Right, it really demystifies it.
Right.
It's less about being a math whiz and more about having a solid process.
Precisely. It's a skill you can learn and apply.
Okay, so wrapping this deep dive up, it really shows the power of converting real-world conditions into these, well, abstract math relationships.
Which leads to a final thought, maybe something a bit provocative for you to consider. Think about problems outside of math. Situations in life that feel messy or complex, or maybe even unsolvable. Where else could you apply this kind of process? Defining the unknown, identifying the key relationships, and working systematically towards clarity or a solution. Could that framework help?